Alright, what's up guys? In this video we're going to pick up with some multivariable calculus. We're going to be talking about triple integrals again. So let's evaluate this triple integral 5x dv. E is the region here. So really all we really need to do here is just set up the triple integral. We can use any of the 6 possible orders. We're just going to have to choose the order that we think would be the best for this triple integral here. Alright, so the way that we want to integrate this, I'm going to use the order dz, dx, dy. That looks like that'll be the best way to do it. So if we do that, that'll be from 0 to 3, from 0 to the square root of 9 minus y squared, and then from 0 to y, and we just got 5x. And then dv, again, I'm just going to do this integral dz, dx, dy. Okay, now when we picked our order dz, dx, dy, you have to make sure that the order here matches up with the integral. So for example, since I want to integrate with respect to z first, then I know that my innermost integral, the one that starts here, needs to be from 0 to y. So I can't have dz as the first variable that I want to integrate with respect to first, and then have from 0 to y placed somewhere back here, exchange with one of those integrals. It needs to match up so that you are getting the correct answer. And then it's just a triple integral at this point. Now, since we're integrating with respect to z first, there's no z anywhere in here, so it's easy to see what we're going to get when we integrate respect to z first. So what we'll have after we integrate respect to z, we'll have our double integral from 0 to 3, from 0 to the square root of 9 minus y squared. And what we'll end up having when we integrate respect to z from 0 to y, we'll end up with 5xy, and then we'll do x dy next. Okay, so now we'll integrate with respect to x. So in this case, I can factor out a 5. I can also factor out a y since I'm integrating respect to x now. And then this would be the integral from 0 to the square root of 9 minus y squared. And all we'll be left with on the inside is x dx. So if we apply the constant multiple rule, we'll get 5y on the outside multiplied by the integral from 0 to the square root of 9 minus y squared. We got x dx, so that's going to be x squared over 2 from 0 to the square root of 9 minus y squared. Now we know that we sub in the upper limit here first. Notice that if I sub in this upper limit, I'll get the square root of 9 minus y squared squared. So since I'm squaring the square root, the only thing that's going to come out is 9 minus y squared. This would be all over 2. Obviously sticking in 0 won't make any change, and this is what we'll be left with. And we still have our 5y, which is on the outside. And then we can go ahead and integrate with respect to our last variable, which would be y in this case. So in this case, I could factor out a 5/2 or a 5 over 2, and then I'll just integrate from 0 to 3. And what I'll end up having is just y times 9 minus y squared integrated with respect to y. I can simplify by distributing in the y. So then I'll have 5/2 or 5 over 2. This would be from 0 to 3. And if I distribute in the y, it looks like I'll get a 9y minus y cubed. And again, it's going to be with respect to y now. So we got our 5/2 on the outside. We'll deal with the 9y from 0 to 3 first. So again, 9 is a constant. You can imagine that that would be factored out for the time being. Then it'll be y squared over 2. We'd have to evaluate from 0 to 3. So essentially, we would end up just having 9 over 2. We would have to multiply by the 9. So that'd give me 81 over 2. And then over here, well, I'll have basically y raised to the fourth over 4 from 0 to 3. So in that case, I think we're going to get 81 over 4, because I know that 3 to the fourth would be 81. And then obviously sticking in the 0 will be good. So now all we need to do is simplify. So we'll have 81 over 2 minus 81 over 4, which I can put in my calculator. So I'll have 81 over 2 minus 81 over 4. And in the calculator, I'll get 81 over 4 with the simplification, which I could kind of see when I first looked at it, but I did want to make sure. And I told you guys about that before. Please run through and use your calculator. Make sure your arithmetic is correct. Everybody's human. It's not uncommon to make a mistake. And all we got to do is multiply straight across this point. I already know what the denominator is going to be. So now I have 5 times 81, which is 405. So this will end up being 405 over 8, which would be the answer. So the final answer for this triple integral here, when we set it up and evaluate, will be 405 over 8. And that's would be the answer. So again, this triple integral wasn't too difficult to deal with. We just set it up and integrate it. And as you can see, the integration in and of itself wasn't too bad at all. So let me circle that for you. Alright, so if you guys got any questions about how I got my answer, please let me know. I'll be more than happy to help you. Alright guys, I'll see y'all next time.